Today we'll be continuing our lesson on the unit circle and finding trig values based on a given angle from on the unit circle. So we're going to do two more examples like we ended with yesterday. So we'll do cosecant of 11 pi over 4, and then we'll do secant of negative 7 pi over 6. So again, step one, we're just going to start with a sketch. So 11 pi over 4, again, get your quadrantal angles labeled. 4 pi over 4 would be over here. Then we're going to have 8 pi over 4, noting here that 11 pi over 4 is bigger than that. So I'm going to keep rotating around. So pi over 2 would have been 2 pi over 4, but to continue wrapping around, it would be 10 pi over 4. So 11 pi over 4 is going to end up in that second quadrant. So that's going to be the terminal side. Rotationally, we're rotating 1 and 3/4 of pi. Now, the second step was to determine the quadrant, which obviously we're in quadrant 2, which if we are in quadrant 2, that means that all students, so the sign value is positive, and the reference angle, again, we look at the denominator, would be pi over 4. And since we're dealing with cosecant this time, cosecant is the reciprocal of sine. So good news, if sine is positive, this also means cosecant would be positive. So our value is going to end up being positive. And then when we go to find the value, what we're going to have to do is, when we use that left-hand trick, we can find the sine value at pi over 4, which is sine of pi over 4, use our trick, would be root 2 over 2. And then we'll just flip that for cosecant. So cosecant of pi over 4 is going to be 2 over root 2, which we have to rationalize. So we'll multiply by root 2 over root 2. And we end up with 2 root 2 over 2, which is nice because the 2's cancel. So cosecant of 11 pi over 4 would be positive root 2. All right, and then I'll switch colors here and do the secant example for negative 7 pi over 6. So again, starting with a sketch. So this time we're rotating negatively, so I will rotate around in a negative manner. So negative 3 pi over 6 would be down here. Negative 6 pi over 6 would be our negative pi value, and then negative 7 pi would be 1 past that. So we're going to end up in that second quadrant. So we're looking at this particular angle for theta. So we are in quadrant 2 again, which we just did. So the sine value is positive. Secant is the reciprocal of cosine. So this time I automatically know that this is going to be a negative value. Our reference angle that we are going to use, looking at the denominator, is pi over 6. So again, I'm going to find the cosine at pi over 6, and then we'll flip it to find secant. So pi over 6, flip down your ring finger in this case. That's going to be root 3 over 2. And then to get secant, we would flip that. Again, we have to rationalize. So this time we get 2 root 3 over 3. And we already put here that this would be negative because of the quadrant that we landed in. But negative 2 root 3 over 3 would be our final answer there. So that's what we do if we are given the angle and we're asked to find the value for a specific trig function. What I want to show you today, in addition to that, is how we go in reverse. We did this with quadrantal angles, but now that we have all of the angles on the unit circle, we're going to take a look at what that looks like for any angle given. So we're going to take a look at sine of theta when it equals negative root 3 over 2. Note here that they did tell us we're limited to just angles within the 0 to 2 pi range, right? So obviously coterminal angles bigger than that would work as well, but we're only going to name angles that fit in that regular unit circle boundary. So a couple steps here, kind of just working through, and it's a lot of just kind of process. There's not necessarily, a right or wrong way to go through this, but this is what I would do if I were you. So the sine value implies here that we're going to be finding y. So what this question I note to start is that I need to know when or where the y value would be negative root 3 over 2. And more importantly, just the root 3 over 2, because again, we can use reference angles and then look at the negative sign to determine a quadrant in a little bit. Which let's talk about quadrants right now. If sine is negative, that's going to happen in quadrants 3 and quadrant 4, because the y value is positive down there because tangent's positive in the third quadrant and cosine, because of calculus, you remember from all students take calculus, is positive in the fourth quadrant. So sine would be negative in both of those. So now, if I use my left hand trick, I have to work backwards this time. Normally we flip down the finger that represents the angle that we're using, but this time I know that the y value is root 3 over 2. So I need 3 fingers on the lower side of the angle that I flipped down. In this case, that should be your pointer finger. So your pointer finger reference angle means pi over 3. So what angles in the third and fourth quadrant have a reference angle of pi over 3? So we need a pi over 3 angle here and a pi over 3 angle here. Well, in quadrant 3, this guy would be 4 pi over 3. And in quadrant 4, we rotate a little further, that would be 5 pi over 3. So our values here for theta, there's 2. It could be 4 pi over 3, or it could be 5 pi over 3. That will give us a sine value of negative root 3 over 2. And again, you can go take a look at your paper plate and double check. But at 4 pi over 3 and 5 pi over 3, the y value should be negative root 3 over 2. Let's try one more. Again, we're going to be looking at the same instructions. This time, though, we're dealing with cotangent. So to start out, cotangent is the reciprocal of tangent. Well, tangent's y over x, so cotangent is saying that x over y, when we divide those two, has to give us root 3 over 3. It is a positive value, so positive cotangent is obviously everything's positive in the first quadrant, and then since cotangent is the reciprocal of tangent, it's also going to be positive in the third quadrant where tangent is positive. So we're looking, final answer here, we're looking for an angle here, and we're looking for an angle over here. And I just randomly sketched those. That's not to imply that they are like the pi over 4s, but that's potentially an answer choice, maybe. Now for this one, unfortunately, your left-hand trick is not as great as it was for the first example because you have to divide to get it to work, right? Because we're doing x over y. So what I did is I actually just took an approach of kind of guess and check. There's only 3 angles that could potentially produce a root 3 over 3 answer. Obviously, 0 and pi over 2 are not going to work, right? Because they're going to give us a 1, a 0, or an undefined. Those are the only options there. So if I just look at the 3 angles in the first quadrant, pi over 6, pi over 4, and pi over 3, I can produce the x over y combination that will get me to root 3 over 2. So for pi over 6, we want to do x over y. So the x coordinate at pi over 6 is root 3 over 2. The y coordinate is 2 over 1, or 1 over 2, but I'm going to flip that. We're going to just multiply by the reciprocal, 2 over 1. And in this case, that gets me positive root 3. So there's the root 3, but I didn't get the over 3 piece out of it. Hopefully you're already seeing how pi over 2 is, or pi over 4 rather, is definitely not going to work because it's the root 2 over 2 comma root 2 over 2. So when you flip that, everything's going to cancel and we get 1. So that one's for sure out, which means it should be pi over 3, but let's check and see. So the x coordinate at pi over 3 is 1/2. The y coordinate is root 3 over 2, so we'll flip that to 2 over root 3 because we multiply by the reciprocal when we're dividing fractions. The 2's cancel, and then maybe you're thinking, oh, wait a minute, that doesn't work. But it does because I'd have to rationalize here. And when I do that, I get root 3 over 3. So in the first quadrant, this angle that I quickly sketched, which is now obviously wrong, would be pi over 3. So that's one answer for the overall question. And then I just need to find the angle in the third quadrant that has a reference of pi over 3. And actually, that's going to be the one we used in the last problem of 4 pi over 3. So again, you're kind of working a little bit backwards in comparison to what we were doing. But again, the steps that we wrote yesterday, you can kind of go in and out of whatever order makes sense to you. what you'll take a look at is on the next page 14, you're going to have some practice problems of this information I just showed you where you're finding the angle measures for theta. So I do want you to go there, and maybe I'll go out and do maybe one more of those before I leave you for today. Okay, so out on page 14, again, maybe I'll just do this first one for one last one. We're asked to find cosine of theta equals 1/2, so what angle measures would make that happen? Again, cosine here is positive. Cosine also is our x value, so we want to know when the x is 1/2. And since it's positive, that would be quadrant 1. And all students take calculus would be quadrant 4 would be cosine positive. So I need to know where those two angles lie. So let's see, if I use my left-hand trick, we want x to be 1/2. So the angle that would put a 1 up on top would be pi over 3. So our reference angle is going to be pi over 3. And that actually would then be an answer because we want the quadrant 1 angle. And then in quadrant 4, 5 pi over 3 would have a reference of pi over 3. So go ahead and try the remaining questions on this page. Feel free to jump back on to the Zoom during our period to ask questions or message me throughout the day, and I will gladly help you with this if you need it. Good luck.